What is a function? Well, before we go and define it, let's go take a look at a different scenario. What about if we looked at it as if it was an input-output relationship? You know, we put something in and we get something out. That means we also have to do something for this input. So let's look at this little machine that I've constructed, or at least a representation of one. Think of it like a wood chipper almost, but instead of it tearing branches and wood apart, we're going to follow a rule. And this time the rule is I'm going to add 3 to it. See this X? I'm going to add 3 to whatever gets shoved into this side. So my inputs, I have 4 different numbers selected here. 1, 0, 100, and -2. Let's see, let's run this number through first. 1 plus 3 is 4. It's not too hard, right? 1 plus 3 is 4. So 1 was our input, 4 was the output. I wonder what would happen if I ran it through there again. Well, let's just try it again. Push 1 through, 4 comes out. If I reversed it, I get a 1. If I push in a 1, I get a 4. So if I took the 100, I'm going to add 3 to it. Now let's do the 0 first. If I put 0 through and add 3 to it, 0 equals 3. So let's write that one out. 0 was my input, 3 was my output. And if I put -2 in, I get +1. What about if I put 100 through? 103. That is a function. It consists of basically an input set of numbers that could have different names. And our answers, after we follow this little function rule or equation, is our output. And that could have different names. And I think that's where functions gets tricky, is where there's all these different names through there. So let's go through and let's take a look at that definition of what is a function again, though, and then we'll take a look at a few other things. Every x value has a unique y value. So a relation is basically where you know that relationship set up where the x values, we could think of this as our input. Every input has its own unique, let's get a little bit of space there, output. Okay, so the inputs we could look at as x's, right? And the outputs we could look at as y's. So let's flip back here and look at this example again that we had. We ran a 1 through this input machine, so this could be known as an x, and the output was a y. 1 plus 3 is 4. 0 plus 3 is 3. -2 plus 3 is 1. 100 plus 3 is 103. And that's basically what it's trying to tell you is that every x value has its own unique y value. And if we wanted to look at this a little bit closer, it's basically saying if I put a 1 through again, I'm going to get a 4 because I add 3 to it. If I put a 0 in again, I'm going to get a 3. If I put it in a third time, I'm still going to get a 3. And so when they say every unique x value has it, excuse me, when every x value has its own unique y value, well, here's the unique x value right here, the 0, 0, and 0. What did the 0 get every time? 3. The 0's unique y value is 3. What is the -2 x values? You know, partners output, it's 1. And so if I put a -2 in again, guess what? I'm going to get 1 again. And you can see where I put 1 in twice. What did it get? 4. And I don't see 100 pop up again, but I'm just going to assume that every time I put 100 in, I'm going to get 103. That's following a function rule. That is a function. Every x value is going to get you the same y value every time. It doesn't mean all their y values are the same, but it means if this number repeats again, going in as an input, it'll get you some sort of number that'll happen again and again and again. So if I put 100 in 10 years from now into this function, it will still get me 103. And then if my grandchildren come along in 50 or 60 years when they're about to retire and they decide to run it through this function, it'll still get them 103. It's part of the function. It's an input-output relationship. Now, um, there's also another thing I'd like to take a look at here real quick, and it says find the range for the relation um, x plus 3 when the domain is -10, 0 0.5, 1, and 5. Oh. Well, that's actually the next questions we have to look at here. What is a relation? What is the domain of a relation? And what is the range of a relation? If we answer these three questions, we're done with today's video. Um, here's range, here's relation, and here's domain. So there you have it. This one problem is going to wrap it up for us today. A relation is nothing more than a set of ordered pairs. Okay. We could show it in an XY table, like this. Remember when we were dealing with linear equations and we'd make XY tables? That whole set of ordered pairs was a relation. Yeah. I could also show it to you like this. 0, 1 is an ordered pair. Here's another ordered pair, 2, 1. Here's another ordered pair, 3, 2. And this set, that we bracket in, this is a relation. It's a set of ordered pairs. That's all that it is. And what is the domain? Well, the domain is just the x values of a relation. We know the relation is a set of ordered pairs, so x, x, and x. The domain of this ordered pair that I have up there is 0, 2, and 3. Okay? What's the range of this relation? It's just the y values. So in this case, it'd be 1, 1, and 2. And I shouldn't have put those parentheses right there, so I apologize for that. It would just be 1 and 2. When you list your domain or range, you always go from least to greatest, put them into the brackets, and if it repeats, don't worry about putting it in twice. See the 1 repeated there for the y's? Don't worry about that, just put it in once. And so when we come back to this question of find the range, well, that just means find the y values. For the relation, that means ordered pairs. X plus 3, what's this talking about? Well, that's your relation. That is your function rule. Okay. Uh, when the domain is, so see these numbers right here are your domain, and that means they're your x values. And a function rule, you could think of it as an input-output machine. So now I can show you this. Our relation is our rule, that's x plus 3. Our domain is our x values, which is the same thing as input. So let me just put domain right here too. You could use these interchangeably. And our range is the same as an output, which is the same as our y values. And I'll go ahead and put x values over here too. So let's go through and just work it out real quick. Let's see. The rule is add 3 to the x. So 1 translates into a 4. 5 is my input or my x value. Add 3 to it and it becomes an 8. Negative 10 will get me negative 7. And 0.5 will get me 3.5. You're not done yet though. It said please find, the range. So the way you would write this out for the last part is you would just write out, here's range, colon. Let's see if I can do a better bracket there. There we go, there's a bracket. And write out your y values from least to greatest. Well, this one's the smallest, so that'll go first. Then it'll be 3.5. Then it'll be 4. And then 8 is our largest value, so that'll be at the very end. and end it with a bracket. That is your answer. Hey, our range is -7, 3.5, 4, and 8. And now you're done.